So let us start with binary operation exercise, introduction of exercise 1.4. Now what does a binary operation mean? Binary basically means 2. If you consider an example where 2 plus 3 plus 4, we always add 2 to 3. It means what? I am adding two numbers first, and the answer what I will get, I will add it to the third number. Okay, so this is how the binary operation takes place. Okay, so now binary operation is always denoted by star operation. Okay, so basically from the beginning itself you have learned four kinds of operations. Those are additions, subtraction, multiplication and division. So whenever you are adding, you are going to add a plus b. Matlab only two numbers you are going to add. Whenever you are subtracting, only two. Dividing, multiplying, only two. Dividing also only two numbers. Okay, so this is what binary operations, two things we are going to choose at a time. Now if you observe here, what is r cross r? Mapping from mapping to r. R cross r is a set of real numbers. A comma b एक set है real numbers है, where a belongs to real number and b also belongs to real number. So r cross r is mapping with r. म्हणजे तुझं आउटपुट काय येणार आहे ना, म्हणजे a comma b. See how it is denoted? Star of a comma b is denoted by a star b. So इकडं मी स्टार घातलो, then a star b घातलो, तर आन्सर मध्ये रियल नंबर मध्ये यायला पाहिजे. अंडरस्टँडिंग? सो if star is nothing but addition, स्टार एडिशन असलं की नाही, मग a प्लस b मला रियल नंबर गावतोय. म्हणजे काय? वेन यू ॲड अ रियल नंबर टू अ रियल नंबर, युअर आउटपुट इज अ रियल नंबर. कळालं ह्याचं डेफिनेशन? आर क्रॉस आर मॅपिंग टू आर. ओके, हां. So now let's come back to the definition of binary operation. What does this say is binary operation star on a set A is a function A star. See here, A cross A है ने, so two sets mapping with A, म्हणजे आउटपुट भी त्याच सेट मध्ये यायला पाहिजे. मतलब this definition what I explained just now. कळालं? So is usually denoted by star of A comma B. For example, plus of a comma b म्हणून म्हटलो की नाही, then it will be कसं डिफाइन केलेलं आहे? स्टार बाजूला होता त्यांच्यामध्ये आला, आता प्लस बाजूला आहे त्यांच्यामध्ये येणार. सो मायनस ऑफ a comma b आला, then it will be a minus b. मल्टिप्लिकेशन आला, then it will be multiplication a and b. Understanding? Okay, so this is basically binary operation का definition. Okay, so let us solve the next sum, that is example 30. Solution: show that the subtraction and division are not binary on set n. So as we have seen in the binary operation definition, whenever you have here subtraction, it means what? For subtraction, definition is minus mapping from. Your binary operation is on which set? Natural number set, no? So therefore minus maps from natural number set cross natural number to capital N, that is natural number once again. Okay, so now if I consider, see, natural number set consists of 1 2 3 and all. 0 is excluded, negative numbers are excluded. Okay, so I'll consider minus of a comma b is defined as what? A minus b. So now for minus of 3 comma 5, which is equals to 3 minus 5, which is equals to minus 2, but what? Minus 2 does not belong to set of natural numbers, therefore this is not a binary. So let us see the second part. Now again the binary operation is defined on set capital N, right? So therefore again division maps from n cross n to n, defined as how? Division of a comma b is equals to a division b. Correct? Now I'll consider 3 comma 4 again. Okay, division of 3 comma 4, which is 3 division 4, which is equals to 3 by 4. Correct? 3 by 4, is it divisible? Even if it is divisible, you will get a decimal number which does not comes under natural number set. Therefore here 3 by 4 does not belong to set of natural numbers. Therefore this is not a binary operation. So let us solve the next question, that is again an example question. Show that inverted V, this symbol is V mapping from R to R, mapping from R cross R to R, given by a comma b is maximum of a and b. So and the another function inverted V, again the same. Here a cross b, I mean a comma b is minimum of a and b, is a binary operation. So first we will put up in statements everything, and then we will show you with an example. Okay, so therefore since V is mapping from R cross R till R is nothing but a comma b is maximum of a comma b, then there exists an unique element in R. Therefore V mapping R cross R is mapping to R is a binary operation. Unique element in R, therefore is a binary operation. Second one bhagya, since same, just you are going to replace the values itself. So minimum of R cross R is mapping from R, given by a comma b is minimum of a comma b. There exists an unique element in R. Therefore inverted V being R cross R given by R is a binary operation. ठीक है? So we wrote these two sets of lines, but इसका meaning तो कुछ ही समझ में आया, but we'll understand it in much deeper. Now we'll consider this function first. V is mapping from R cross R given till R. Now a comma b तुम्ही असला नंबर चूज करणार आहे ने जे रियल नंबरच्या सेट मधनं असणार आहे. ओके, रियल नंबरच्या सेट मधनं कुठलं बी नंबर मला उचलून दाखवा, विच एव्हर यू वॉन्ट. आय विल टेक 4 and 9. हे रियल नंबर मधनं आहे, हे बी रियल नंबर मधनं आहे. सो व्हॉट इज डेफिनेशन काय आहे? मॅक्सिमम ऑफ 4,9. 4 आणि 9 मधलं मॅक्सिमम नंबर कुठला आहे? 9. युअर आन्सर इज 9. डज दिस 9 बिलॉंग टू रियल नंबर? म्हणजे ऑफकोर्स आहे ना, बिकॉज रियल नंबर मधनच उचलला असतो आणि रियल नंबर असणारच आहे. यू आर डिरेक्टली गोइंग टू गेट द रियल नंबर. सो दिस इज व्हॉट दिस डेफिनेशन मीन्स. ओके, ॲज सिम्पल ॲज दॅट. सो ना हे डेफिनेशन मधनं मी बघा, आणि तुम्ही रियल नंबर मधनच उचलणार आहे, त्याला तुम्ही ॲडिशन, मल्टिप्लिकेशन, सबट्रॅक्शन काय करणार बी नाही आहे, बट यू आर गोइंग टू जस्ट कीप दॅट नंबर ॲज इट इज. सो if I take 4 and 9 again, then it is what? Minimum of 4,9. बरोबर. So answer is 4. 4 high, 4 belongs to a real number, therefore it is a binary operation. So now let us introduce operation table. Operation table is basically for the sets which are very less in number. For example, let set A is equals to 1, 2, 3 and 4. Now the same definition I will use from this question. This V is mapping from, it means maximum is mapping from A cross A to A. Then what you will get is, now hey ani 4 वेळा you have to write the whole procedure once again, no? So therefore we introduce this table where I'll write 1, 2, 3 and 4. 1, 2, 3 and 4. Now so V चं definition काय आहे? Maximum. Okay, so 1 आणि 1 मध्ये maximum कुठला आहे? 1च. So here you are going to fill with 1. 1 आणि 2 मध्ये maximum कुठला आहे? 2. Between the 1 and 3 which is the maximum? 3. So this will be 4. Okay, 2 आणि 1 मध्ये 2, 2 आणि 2 मध्ये 2, 3, 3, 2, 4, 4. This will be 3, 3, 3, 4, 4, 4, 4 and 4. Okay, so basically this becomes a very shortcut method for operation table. This operation table in general, if you want to represent, then number of columns will be A1, A2, A3 so on up till n. where n will be number of columns, n is number of columns, and this a1, a2, a3 are the elements that you will be putting over here, and the empty box which remains over here you will fill the function whatever they have given. Understood? So this is basically known as operation table. Let us continue with the topic. So today we are going to continuation part of binary operation. So the next definition that we have is commutative definition. So what it is telling us is a binary operation star on the set X. असं कुठलंही सेट घ्या जे सेट X म्हणून असतंय is called commutative if and only if when A star B is equals to B star A. ह्याचा अर्थ समजूया पहिला. ठीक आहे. सो दिस इज युअर बेसिक डेफिनेशन. व्हॉट वी अंडरस्टँड फ्रॉम दिस इज, बाबा दुसरे कुठले तरी टोन मिळतात की नाही. ओके. सो स्टार म्हणजे काय? स्टार कॅन टेक विच ऑल व्हॅल्यूज. स्टार कॅन बी प्लस, मायनस, ॲडिशन, डिव्हिजन, मल्टिप्लिकेशन, HCF, LCM, so on. Okay. It has many definitions of star. Now if you observe, प्लस कडनं सुरू करूया. ठीक आहे. प्लस कडनं सुरू करूया. A प्लस B इज इक्वल्स टू B प्लस A. ट्रू आहे का फॉल्स आहे? ट्रू. वाय? बिकॉज 3 प्लस 4 इज इक्वल्स टू 4 प्लस 3. दोघांचा आन्सर 7 बरोबर आहे. ठीक आहे. नाउ लेट अस चेक ऑन मायनस. A minus B is equals to B minus A. True है? False है. Why it is false? Because 3 minus 4 is not equal to 4 minus 3. It will become minus 1 plus 1. Okay, or vice versa. However it is. So आता कळालं commutative म्हणजे काय? So it can take n number of things. Now if you consider multiplication, 3 into 4 is equals to 4 into 3. सगळा आन्सर बराबर. ठीक आहे. So still this works. Now this is nothing but your commutative thing. ठीक है. So it is having many different sums in our exercise. We will see until then. So let us see the next example on commutative property. So here they are telling that plus is mapping from R cross R to R and multiplication is mapping from R cross R till R. Show that it is binary and subtraction is also mapping the same and division is also mapping the same are not commutative. Okay. तर वरचं commutative हाय आणि खालचं commutative नाही आहे म्हणून दाखवायचं. Okay. So it is very simple. See over here. Now we know that plus mapping R cross R till R. So binary operation which is equal to A plus B is equals to B plus A. Correct? A plus B is equals to B plus A for all where A comma B belonging to R. Belonging to R कशाला? इकडे बघा. R cross R आहे ना till R. So therefore एवढं लिहायचं. एवढं माहित झालं. This is for addition and for multiplication. For multiplication is mapping from R cross R till R where A into B is equals to B into A. True है? Is true for all A comma B belonging to R. ठीक है. So these two lines are satisfying. Therefore what we can say? Addition and multiplication are commutative. Commutative and binary operation. ठीक है. Now coming to the second part, what you can show here, plus हे ॲडिशन बरोबर कॉम्युटेटिव्ह हाय म्हणून दाखवायला तुम्हाला रिअल नंबर मध्ये किती नंबर्स येतात बघ, सगळ्यांना इन्क्लूड करायला लागतंय. ठीक आहे. बट टू शो इट इज नॉट बायनरी एक एक्झाम्पल घेऊन दाखव. ठीक आहे. एकच एक्झाम्पल घेऊन दाखव की ते हे व्हायचं नाही, कॉम्पिटेटिव्ह होत नाही म्हणून. एक एक्झाम्पल बस. ठीक आहे. सो देअरफॉर नाव 3 minus 4 is not equals to 4 minus 3. बरोबर. So therefore for all 3, 4 belonging to R belongs to R. Correct ne? Therefore minus is not binary operation. I mean minus is not commutative. is not commutative. And even if you see here, for the same example, 3 divided by 4 is not equal to 4 divided by 3. Okay, so two different values you will get, no? For all 3 comma 4 belongs to R, therefore division is not commutative. Division is not commutative. Understood? Very simple sum. इथं तुम्ही कुठलाही नंबर घ्या रिअल नंबर्स मधनं, प्लस करा, हे फंक्शन हे स्टेटमेंट सॅटिस्फाय होतंच, आणि इथं मल्टिप्लिकेशन मध्ये कुठलाही सॅटिस्फाय होणारच. ठीक आहे. सो लेट अस अंडरस्टँड द नेक्स्ट डेफिनेशन दॅट्स ऑन द बोर्ड. So which is your next definition is associative. So what it is saying, a binary operation star, that is A cross A to A, is said to be associative if A star B is equals to B star A. इसका मतलब क्या समझो? See, there is association going on between them, B star C. So as told earlier also, star can take many operations. Okay, plus असलं, minus, addition, division, subtraction, काय भी असू दे ते separate येणार. Now you are going to first add, subtract, काय भी असू दे, we will choose a particular example so that it will be easy for us. Okay, so now if you see here, A plus B plus C, आणि इथं प्लस A साइडला आहे B plus C, म्हणजे काय करणार आहे मी, वी आर गोइंग टू ऍड ए बी फर्स्ट. पहिला ए बी ऍड करणार, जे आन्सर गावतंय ने त्याला सी ऍड करणार. ठीक आहे. अँड इन दिस केस ए ला बाजूलाच ठेवूया, बी आणि सी ला पहिला ऍड करणार, त्याच्यानंतर ऍड ए. ओके, हे जे आन्सर गावतंय त्याला ऍड करणार. ठीक आहे. नाउ ऍडिशन इज हाउएवर कॉम्युटेटिव्ह. ठीक आहे. बट in case of subtraction and in case of division, this does not hold good. Okay, so let us see one example based on this associative property. So what he is telling is, show that R is an associative on addition and multiplication, but it is not associative on subtraction and division. Okay, operation is on R. Okay, so now addition and multiplication are associative. So what we can do is A plus B plus C associate with A and B. Now A plus B plus C associated with B plus C. This holds good. Correct आहे ना. कुठलाही नंबर चूज करा रियल नंबर्स मधनं, you will satisfy this case. Okay, for all A comma B comma C belonging to real number is true. Okay, and A into B into C is equals to A into B into C for all A, B, C belongs to R. It means what? Therefore addition is a binary operation on the set R. फक्त addition ने, even multiplication, therefore multiplication is a binary operation on the set R. ठीक है. now कळालंय. सी, this case satisfies for all numbers. failure case मध्ये एकच चूज करायचं असतं. you need to choose only one thing. now I'll choose 8 plus 5 plus 3. okay, sorry, it is not plus, काय आहे, सबस्ट्रॅक्शन आहे ना पहिला. so we will choose this. association कसं करूया, फर्स्ट दोन मध्ये करूया, नंतर थर्ड वन. ओके, सो लेट अस राइट दिस अनदर सेट. नाउ व्हाट इज 8 minus 5? 8 minus 5 is positive 3. This is negative 3. It is 8 minus 5, minus into minus is plus 3 होता है. कळाला? आत मल्टीप्लाय होणार नाही. सो नाउ minus 5 plus 3, minus 2 होता है. नाउ 8 minus 2 is 6. This is, and these two are not equal. बराबर नहीं. So therefore subtraction is not a binary, is not an associative. Therefore subtraction is not an associative. And division ला भी same. 8 by 5 by 3. हे नहीं है, choose करा 8 by 5 by 3. So now if you observe 8 by 5, 8 divided by 5 by 3. Of course, that therefore these two, therefore division is not an associative binary operation. Division is not associative binary operation. Here also addition is not addition is associative binary operation on the set R. Okay, in the same mode. Okay, so let us see the next kind of definition. So this is an identity element definition. What it is telling us is A star is mapping from A cross A till A if there exists an element in the set A such that A star E is equals to A star A. A star E should be equal to A and E star A also should be equal to A. Okay, so this is known as an identity element. So now if you see here I'll consider A, let A be any number from the set A. Now tell me one such number, if I add to this then my answer should be A itself. 0. So therefore addition bana lo, then it will be 0. It means what? A plus 0 is equals to A itself, and reverse bhi check karala paise ne. So 0 plus A is what? A itself. It means what? This condition is satisfied for all A belongs to A म्हणालेत, म्हणजे कुठलाही तू नंबर चूज करायलाच नाही हे A ते ह्या सेट मधनं असायला पाहिजे, A सेट मधनं. ओके, 0 is the identity element in addition. ठीक है? Now let us see the next kind of thing. Now I'll give you A into, I want some value so that I should get my back the question itself. काय नंबर सिलेक्ट केल्याने तेच वापस यायला पाहिजे. And if you observe, it is of course 1, correct no? 10 into 1 is 10, 100 into 1 100. तो तसं 1 into A is also equal to A, म्हणजे दोन्ही कंडिशन सॅटिस्फाय झाले आणि एकदा. So therefore now 1 is the identity element in multiplication. So listen, let us study this next definition based on invertibility and inverse. So what is the basic definition? क्या बोल रहा है कि the output what you are getting should be an identity element. म्हणजे काय आहे, A star B is equals to E म्हणालाय त्यानं. म्हणजे if I have -2 आहे माझ्याकडं and स्टारच्या बदली मी प्लस लिहिणार आहे and I want such a number B that I should get identity element, that is identity element is 0, right? In addition identity element काय है 0 है. So therefore your answer should be 0. So आता -2 आहे, इथं कुठलं नंबर काढल्यावरती 0 येणार आहे? +2. So therefore +2 is your A inverse. काय म्हणाले त्यांनी? Such that A star B is equals to E आणि B star A ते वेगळं is B is called the inverse. B म्हणजे कुठलं? सेकंड टर्म नाही, सेकंड टर्म is called A inverse. ठीक आहे, A चं इनवर्स कोण? द सेकंड टर्म. इट मीन्स व्हॉट? -2 +2 0. ओके, इन केस ऑफ मल्टिप्लिकेशन सपोज माझ्याकडे 2 आहे, आय नीड मल्टिप्लिकेशन ऑफ असलं एक नंबर पाहिजे ने, माझा आन्सर 1 यायला पाहिजे. 1 कशाला? बिकॉज मल्टिप्लिकेशन का आइडेंटिटी एलिमेंट कौन सा है? 1 है ने. सो देयरफॉर व्हॉट शुड बी द व्हॅल्यू ओव्हर हियर? असलं एक व्हॅल्यू सांगा की 2 बरोबर मल्टिप्लाय केल्यावरती आन्सर 1 यायला पाहिजे. 1/2 एक नंबर आहे ने, सो 2 आणि 2 कॅन्सल केल्यावरती आन्सर रियल नंबर 1. ओके, your mapping is from R to R, okay, R cross R to R. So therefore you can consider fractions also. Understood? So this is nothing but A inverse.